Hello students, in the last lecture we did AC circuit containing resistor only. Now before moving to the other topic, that is AC circuit containing only inductor or capacitor, we have to understand the concept of a phasor or a rotating vector. In a circuit which was containing only the resistance, the current and the voltage were in the same phase. That is, as the voltage increases, the current also increases, and as the voltage decreases, the current also decreases with the same phase. That is, the phase difference was 0, and it was clear from the equation where the instantaneous voltage of the source was V is equal to Vm sin omega t, where this was the voltage of an AC source which is a function of time. So it was called as an instantaneous voltage. And for AC circuit containing only the resistor, the current equation comes out to be Im sin of omega t. So both were the function of sine. So the phase difference was 0. But this is not the case with the AC circuit containing capacitor or an inductor. In such circuits, or in a circuit which contains either inductor or a capacitor, the current lead or lags the voltage. That is, they are not in the same phase. The current is established after some time, or the current is established before the voltage. That is, lag and leading concepts are there. Now to understand clearly this concept of leading and lagging of the current or a phase difference, we introduce a concept of a phasor. So phasor is nothing but a pictorial representation of the current and the voltage in the circuit. So from the pictorial representation, or we call it a phasor diagram, we will easily find out whether the current leads or lags the voltage and by how much degree. Here the phase difference, if we talk about this AC circuit containing, this was AC circuit containing resistor only. And if I say what is the phase difference, that is the angle. So phase difference, let us denote that phase difference by phi, then it was 0. So now what is this phasor and what is a phasor diagram? Now we know that the voltage and the current are the scalar quantity. Voltage and current both are the scalar quantity. But in this chapter, the voltage and the current are the function of time, and or you can say they are the function of sine. So their value keeps on changing with respect to time. As well, their direction also changes. That is, their polarity also changes, because the range of the sine or cosine function is from -1 to +1. So the behavior of this V and I is that of vectors. Now what is a vector quantity? The quantity which have a magnitude as well as direction. So that was called as a vector quantity. Now though potential or voltage or an electric current is a scalar quantity, but here their behavior is like a vector. But we cannot call the voltage and a current as a vector quantity. So we introduced a new name and represent or call them a phasor. So phasor is nothing but a rotating vector which rotates. And if a vector rotates, its magnitude or the amplitude or a peak value will remain constant. What is the peak value of V? Vm. The peak value of I? Im. So this peak value will remain constant, but the overall value of V, that is instantaneous voltage and instantaneous current, will change. So we represent V and I by a new terminology which is called as a phasor. So phasor is nothing but a rotating vector. A rotating vector here means whose value or a direction will change with respect to time, and its magnitude or the peak value, or you call it amplitude, will remain constant. So like in 11th, suppose we take a vector A. So this was vector A, and suppose it makes an angle theta. Now we resolve this vector into the two components, and this one component was referred as A cos theta and the vertical component was referred as A sin theta, where A was the magnitude of A vector. Now as this vector rotates, it means if the angle changes, and if you remember, this omega t is nothing but a theta. So in AC generator, we replace this angular displacement by omega t. So this is our theta. So as theta changes, or if this vector rotates, its magnitude or its horizontal or the vertical component will keeps on changing, where this magnitude, suppose the length of this vector is say 5 meter. So even if this vector rotate, the length will remain 5 meter only. So here we will be representing a voltage and current, that is AC voltage and AC current, by a phasor. We call them phasor, and the symbol will be a bold capital V and capital I. So phasor is nothing but a vector which rotates about an origin with angular frequency omega. So first we defined what is phasor. So a phasor is a vector which rotates about the origin with angular frequency omega. So a phasor is nothing but a vector which rotates about the origin with an angular frequency omega. So instead of this theta, we call it, we discuss the thing in the terms of the angular frequency omega. Phasor diagram. So the phasor diagram will be helpful to understand what is the phase difference between the AC voltage and the AC current. So phasor of AC voltage is denoted by, again we introduce a capital V. Here we draw or write a V a little bit in a bold form, because in the last lecture we have seen capital V and capital I in this chapter also represent the RMS value of the voltage. So a phasor of AC voltage is denoted by capital V, and phasor of AC current is denoted by, again capital I, but we represent it by a little bit bold sign. So this capital V and I, they are not, or the AC voltage and AC current are not the vector quantity, but we will treat them as a vector. So now in the coming topic, we will treat this voltage, that is a AC voltage and AC current, by we will treat them as a vector, and we know the vector will change its direction. Here they will change the direction in the terms of a polarity and in the terms of a value. Then we will draw a phasor diagram also. We will see how to draw the phasor diagram. Now what is a phasor diagram? A phasor diagram is a diagram which represent the phase difference between V and I. That is, it will indicate by how much difference the current is leading or lagging. So a phasor diagram a diagram which represent the phasor, V, it represents the phasor V and phasor I along with their phase difference. So this diagram is a diagram which will represent the phasor V and phasor I along with their phase difference. So we will see how to draw the phasor. So V and I, also you have to keep this in mind. V and I are scalar quantities, but we treat them like a vector. That is, we cannot call them a vector. So we named it or we introduced a new notion or a new concept which is called as phasor. Now, simply whenever I say phasor V, I mean a V which will rotate about our origin with angular frequency omega. So now let us see how to draw the phasor. Simply, it resembles similar to the concept of vectors where we will take a horizontal and the vertical component. So suppose I want to draw a phasor diagram of AC voltage only. So only AC voltage. Phasor diagram of AC voltage. So suppose I have to draw a phasor diagram of AC voltage only. So I will draw this diagram as, I will put a capital V, a little bit bold. For suppose I want to draw the phasor of this angle will be termed as omega t, and the magnitude of this vector is Vm. So this magnitude is Vm. So it is similar to a vector A. So in the place of A vector, we represent V. The magnitude of A vector is A. Here the magnitude or the peak value or the amplitude of this vector is Vm. And now this vector will rotate. Rotate means the angle will increase. So suppose this angle is 30 degree. So I will write the AC voltage at that particular instant is V is equal to Vm sine of 30. Then after few seconds or as the time increases, this phasor will also rotate. Suppose this phasor comes to this point, then what will be the angle? Sine 90. That is omega t will be 90. So I will write V is equal to Vm. That is, in the circuit, the voltage is maximum. And this phasor keeps on rotating. So we call a phasor is a vector which rotate about the origin with angular frequency omega. So angular frequency is omega, and omega multiplied by t, that is angular velocity multiplied by t, is angular displacement. So this is a phasor diagram of AC voltage. So as this phasor rotate, and we know the unit circle rotate in anti-clockwise direction, so we will rotate this phasor in anti-clockwise direction. Now simply our voltage, AC voltage, is a function of sine, that is sinusoidal varying. So this will be the vertical component. So if I want to find out on the phasor diagram where is Vm sine omega t, so we have only vertical component, and here I am going to write this magnitude, that is Vm component sine omega t. So the vertical component of phasor V. Whenever we write phasor, we write this in a bold capital letter. So vertical component of phasor V is Vm sine of omega t, that is sinusoidal function, or it is a function of sine. So sinusoidically it vary. It means it is a function of time. It is a function of sine. So this is only the phasor of phasor diagram of AC voltage. Now as this value changes, theta changes, the value of the instantaneous voltage will also keep on changing. So this there will be advantage of this diagram where we will easily find out what is the phase difference between V and I. We will combine the phasor diagram of AC voltage as well as AC current, and as they rotate, they form a graph of sine and cosine. So we will see the phasor diagram of AC circuit containing only resistance also. So similarly, if I want to draw a phasor diagram, so vertical component is important for us because here we have sine component. Suppose we have a cosine component here, then it will be the horizontal component of the a phasor V. So you have to make a components. So now we will say the phasor diagram of AC circuit containing only a resistor. So you have to keep this in mind that phasor is nothing but a vector, and the AC voltage or current are a scalar quantity, but because their values are changing continuously as well as they change their direction, or we can say they change their polarity. If the current is flowing in a clockwise direction, then after 180 degree or after t/2 time, that is the half cycle, the polarity is reversed. That was the concept of a AC generator. So we studied in AC generator how the polarity changes. So this vector keeps on rotating, and when this vector rotates, the graph will be formed, and that graph will be the graph of a sine or cosine. We will see. So this is the vertical component. Also you have to remember the amplitude or peak value of phasor. So whenever I write phasor, capital V bold is Vm. So it is like we have a vector V whose amplitude or the peak value is Vm, that is its peak value Vm. So whenever we make a component, the vertical component is a sine and the horizontal component is cosine. We have to see the equation, and accordingly we will make a diagram. So this was a phasor diagram of AC voltage. Similarly, we can draw a phasor diagram of AC current also separately, but we have to combine this both the diagram to understand what is the phase difference between the current and the voltage. So let us see the phasor diagram of AC circuit containing resistor only. Now this phasor diagram can be easily drawn with the help of the equation which we have derived. So first we derived this equation, and we write a phase difference between them was 0. So one is the mathematical treatment and one is the graphical treatment, which is a phasor diagram. So suppose I have to draw the phasor diagram of AC circuit containing only the resistance. So let us see how we will draw this thing. Now suppose I want to draw the phasor diagram of this circuit. So we know the graph. V was a function of sine. So in the last lecture, we draw the graph of Vi versus omega t. So this was the graph of sine graph. This is your V, and this value was Vm. Similarly, we draw the sine graph, the graph of current, which is also the function of sine. So this was I. Now from this, and this was the peak value, that was Im. This is In, that is its peak value. Now this time, or this angle, omega t means angle, so it is pi, that is 180 degree. This is 2 pi, that is 1 complete half second. In the terms of time, it is t by 2, and this is t, that is 1 complete second. Now let us draw the phasor at any time t1. So phasor diagram of AC circuit containing resistor at any time, say t1. So we take a common time, like this, we drop a perpendicular. This is called as omega t1. This is omega t1. So t1 will be provided to you, and omega is known, so it will give you the value of omega into t1. So you drop that common point. Now we draw a horizontal line connecting the V and join this. And we call it V. So we draw it a bold. Similarly, draw a horizontal line. This portion will be phasor I. And now this angle, if we name this as omega t1, this is angle is omega t1. So there are two vectors. One is V and one is I, and they are overlapping. So what is the phase difference between them? The phase difference is 0. Now as V rotates, the I will also rotate. For example, we know that this angle is 180 degree. So in the terms of angle, this angle is 90 degree. So when the coil in the AC generator becomes 90 degree, this was the situation. So suppose this angle is 30 degree. So this is the phasor, or omega t1 is equal to 30 degree. Now both will rotate simultaneously, and their phase difference will be 0. So this is simply a phasor diagram. Now if I drop a perpendicular, because I have to deal with vertical component only. So this length, the magnitude of this is Vm. So this entire length is Vm sine of omega t1. And if I drop a perpendicular here, this vector will be written as Im sine of omega t1. Now see this. Suppose I take this point. What is this point? This point is 90 degree. This is at any instant t1. So as it rotates, suppose this phasor V and I become parallel to y-axis, or it comes across in the direction of the y-axis. Then at that time, if I drop this perpendicular line, the angle will be 90 degree. Then this angle will be, suppose above 90, say 100. So the vector will be at this point. When this graph comes to this point, the phasor will be like this. When this graph comes to this point, this is angle 270. At that time, phasor will be at this point. Then 360. At any instant, we can draw this phasor. So this is the phasor at time t1. So this is how we represent the phasor diagram. So instead of the graph of sine or cosine, sometime we deal with a phasor diagram. Suppose I draw the phasor diagram like this now. Suppose this is phasor V, and suppose I draw I like this in such a way that this angle is 90. Now remember, the unit vector or phasor always rotate in anti-clockwise direction. So what will happen? The angle between I and V is 90 degree. The angle between I and V is 90 degree. So in this case, I will say I leads the voltage by pi by 2 radian or 90 degree. Now after some instant, suppose this V comes to this axis, on this axis, this is I, then V will also rotate, then V becomes like that. Again the phase difference is 90 degree. After some instant, if I comes on the negative y axis, then V will come along the negative x-axis. Again the phase difference is 90 degree. So from this diagram we can easily find out. Now this does not happen in this circuit because V and I are in the same phase. V and I are in the same phase. But in the coming lecture we will see when we have an inductor or a capacitor, the current leads or lags the voltage by some fixed degree. So angle between the V and I will remain fixed. Suppose this is an angle 30. This is an angle 30. So this entire angle will be equal to 120 degree. So again the angle between these two vectors becomes 90. Again if this becomes V becomes 90 degree, then I becomes 180 degree. Again the angle is 90 degree. So I will say I leads the voltage by pi by 2. Now this is not the case in a resistor because both increase, decrease or becomes 0 at the same time. So we have a phasor on the same line, and the vertical component will give you the instantaneous voltage and the instantaneous current. So you have to remember the vertical component of the phasor will give you instantaneous voltage and instantaneous current, where the amplitude or the peak value of the phasor is Vm or Im. So this is the graph for this. Now please note down or you see this graph properly. This is at instant omega t1. Suppose I want to draw the phasor diagram, say at this instant. Suppose I want to draw the phasor diagram at this instant. So this is say omega t2. So what you have to do is you drop a perpendicular. Now this becomes V and this phasor becomes I. Again this is the situation. So that is a peak value. We know this is a peak value Vm. So this is your Vm now. This is, and what is angle? 90. You put that sin 90 Vm, sin 90 Im. So this will become Vm and this will become Im. So I will say this is a phasor diagram and this angle value will be equal to omega t2. So this is again from the graph I can easily say V and I are in the same phase, and at this instant, which instant? T2 instant, their angle from the origin is 90. So I will substitute this omega t2 or omega t90 there, and I will find out the maximum. In this case it will be the maximum value. Suppose I want to draw the phasor diagram at this time. Now let us say another time. This phasor means a rotating vector. So you remember the definition. What is a phasor? Phasor is a vector which rotates about an origin with angular frequency omega. Now suppose you say you draw the phasor diagram at this instant. Let this instant is omega t3. then how will you draw the phasor diagram? Clearly, we know that this angle is 90 degree, this is pi, so it is more than 90. So again you draw the component, and from this also I join this line, this is V and this is capital I, again their amplitude is Vm. Now this angle is omega T3. So that is more than 90 degrees, say 100 degree. So I substitute 100, sine 100, sine 100 and find out the instantaneous value also. So we have this sine graph, and along with this sine graph we have a phasor diagram. As the phasor rotates, or you can say as the time changes, V and I will be in the same phase always, but their value will keep on increasing with respect to x-axis. The angle will increase, so sine value will also increase, and at some point the range will be from +1 to -1. So this is the phasor at this time. Suppose I want to draw the phasor at this. We know this is 180 degree. So I will draw the phasor at this capital V and capital I. So this will be the situation for the phasor at 180 degree, because if I drop a perpendicular, if I take a horizontal component, it comes to this line. Suppose you want to draw the phasor diagram at this point. Now what is this angle? This is 270 degree. So I drop this perpendicular, this becomes capital V. From this it will become capital I. This value will be equal to Im, and this value will be equal to Vm. And because we are in negative x-axis, we call this minus Im minus Vm. Else you substitute 270 sine 270, that will be the -1 value. So this is how the phasor is drawn, and as this vector rotates, or now we will not be saying vector, we call it a phasor. As this phasor rotates, they form a sinusoidal graph or a sine graph. They draw a sinusoidal or a sine graph. So you are either you deal with this graph of sine and cosine, or you deal with the phasor. It will be very easy to find out whether the current lags or leads the voltage. So you can draw the phasor diagram at any instant, and we will see the advantage of this phasor diagram, where we will be able to instantly reply whether the current is leading or lagging. So one portion we have a mathematical treatment, the other portion is a treatment by a phasor diagram, and we have drawn this phasor diagram at any instant. This was an instant. This instant is omega t1. So this is capital V and this is capital I, a bold capital V and I. And you have to remember this amplitude is Vm. So this portion is Vm sine omega t, and this portion is Im sine omega t1, whatever is the angle at that time. So we will again see the phasor diagram in AC circuit containing only inductor and capacitor. We introduced this concept of phasor because the current lags or lead if the circuit contains an inductor or a capacitor, though it was not the case with this circuit of resistor. It was a simple circuit. So we will continue with AC circuit containing only inductor in the next lecture. In all the three topics, whether it is a resistor, inductor or capacitor, we have to find out V, instantaneous V, that is fixed, that is our AC source, AC generator, which we connected across resistor or inductor or capacitor. So this equation remains fixed. I will keep on changing. The I will keep on changing because it may lead or lags the voltage. So I will change. So first question will be to find out the expression for the instantaneous current in the circuits containing R or L or C. And after finding out the instantaneous current, we draw the graph of VI, whether they are sine or cosine graph. From this graph, we will also draw the phasor diagram. That is another second part of the question, and the another third part is always find out the instantaneous power or average power. We have seen that average power for this circuit was I square R. The symbol was introduced because we can connect it with chapter 3 or DC source. Otherwise, this I is nothing but IRMS value, and this capital V is nothing but it is an average power. So symbol remains same as that of DC chapter, but their physical meaning has changed. So in all the circuits we will find out the power also. Have a nice day.